Suppose that the relation H is defined as follows. H equals the set containing the ordered pairs 5, m, 2, 5, 6, q, 6, 0. So all that a relation is a set of ordered pairs. And remember, in an ordered pair, the first value is x, the second value is y. When we're talking about relations and functions, the x value is referred to as the domain, and the y value is referred to as the range. So the directions say write our answers using set notation. So the domain would use braces, and we'd list only one time all the first elements, the x elements, which we're calling the domain. So that would be 5, 2, and 6. Remember, we only list them one time. Now the range would be our y values. M, 5, Q, and 0. Next question, for each relation, decide whether or not it is a function. So a function is a relation where the domain is only paired with a single range element. So, for instance, if we had a relation this would be a function because if you look at the domain, it's not repeating. Now, if it happens to repeat, it's okay as long as it has the same range value. So, an instance where we wouldn't have a function would be if we had something like this. The set containing the ordered pairs 1, 2, 3, 5, and 1, 6. Notice that we have a duplication with our domain, and it is paired with a different range value. So when we're looking at these diagrams, we're making sure that the domain is only paired with a single range element. So in this case, the first relation, lake only has one line going from it. So does sky, so does pen, and so does cloud. So in this case, this would be a function. Now, when we look at relation 2, we notice that the domain value 7 is going to two different range values. So if this occurs with any domain, it doesn't have to occur more than once. If it occurs with any domain value, then this would be considered not a function. Let's look at a couple more. Relation 3. So the first thing we're going to do is look at our domains, T, K, G, and U. Notice there's no duplication. So we know that this is a function. Relation 4. Again, we're going to look at our domains, 6, 5, 6, and 6. Notice we have a duplication with the domain value 6. It's paired with V, then S, and then W. Since our range values are different, this would not be a function. Now, if we're given graphs and we're determining whether or not the graph represents a function, remember the rule that our domain can only be paired with a single range value. So we use something that's called the vertical line test. So the vertical line test states that when we draw a vertical line anywhere on the graph, in order for it to be a function, it cannot hit more than one point. So I'm going to start with graph 2 to show you what I mean. So in graph 2, if I drew a vertical line here, you notice that it hits our graph in two different places. Therefore, this would not be representative of a function. Now, graph 1, there's no place on this graph where we draw a vertical line and it will intersect a range value in more than one place. So remember that this open circle means that this point is not included. So there's nowhere that we draw a vertical line and it hits our graph in more than one place. So this would be a function. Graph 3. So again, using a vertical line, I notice if I drew the vertical line at x equals -1, it intersects two different points. Therefore, this is not a function. Graph 4. Again, there is no place that I draw a vertical line and it will intersect this graph in more than one place. So yes, this would be a function. Using the vertical line test for graph 5, if I drew a vertical line here, it intersects my graph in two places. Therefore, it is not a function. In the last example, graph 6, again, there's no place where I could draw a vertical line and that same vertical line intersect more than one point. So therefore, yes, this would be a function. Now let's talk about function notation in evaluating a function. So in function notation, we use a letter to name the function. It could be any letter. So here we have two different functions, f and g. Now what we have in parentheses, this variable, represents the variable in the given function. So whatever is in that place would be where, in this case, the x would be within our function. And again, for the g function, it's the same thing. We have g of x. That's why we have 3. And in that place, x to the third. So f of x is the same thing as y. So when we're evaluating this function, the answer we get represents our y value, which remember we now call the range. So let's look at our examples. We have f of x equaling 2x plus 4 and g of x equaling 3x to the third plus 5. So to evaluate the function, there's two different problems here. The first one is evaluate f at -3. So Notice that negative 3 takes the place of x. So negative 3 is our x, or our domain value. So our original f function, because this is the one it's telling us to use, that's why it says f of negative 3, we replace the x with negative 3. So instead of it being 2x plus 4, it's 2 times negative 3 plus 4. So the only thing that changed is the value in parentheses, this time negative 3, replaces the x everywhere you see it in the function. Now we follow our order of operations. And all we're doing is working what's to the right of our equal sign. So we start with multiplication here. 2 times negative 3 is negative 6. And negative 6 plus 4 is negative 2. So f of negative 3 equals negative 2. So as an ordered pair, we use negative 3 for x, and our result was negative 2. So domain negative 3, range negative 2. Let's do the next one. And the second one says evaluate g at negative 4. So which function do we use? It's telling us to use the g function. So negative 4 replaces the x. So now instead of it being 3x cubed, or 3x to the third power plus 5, it's 3 times negative 4 to the third power plus 5. So again, we follow our order of operations, and we're going to go ahead and do our exponent first. So negative 4 to the third power is negative 64 plus 5. So next we do our multiplication. So we multiply 3 times negative 64, and that gives us negative 192. And next we add negative 192 plus 5, and that gives us negative 187. So g of negative 4 equals negative 187. So again, if we wanted to write it as an ordered pair, negative 4 is what we use for x, and our y value, or our range value, is negative 187. Our next question is to complete the function table. So here we're given a function f of x equaling negative 4x minus 3, and it's telling us what we're using to substitute in for x. And remember, f of x is the same thing as y, so that's going to be our y column, or our f of x answer, after we plug in these values for x. So the first one we're evaluating is f at negative 1. So again, we're going to replace x in the function with negative 1. So we have negative 4 times negative 1 minus 3. Following our order of operations, negative 4 times negative 1 is positive 4. And 4 minus 3 is 1. So in our f of x column, we put 1. And let's do one more. So the next one, we're evaluating f at 0. So again, we come to our defined function, f of x equals negative 4x minus 3, and in place of x, we're going to put 0. So again, following our order of operations, negative 4 times 0 is 0, and 0 minus 3 is negative 3. So you would do this for the entire table. Our next problem. The function h is defined by h of x equals x minus 6 over 3x plus 7, and we're asked to find h of 5x. So what we do is, again, we take the function given, and in place of x, we're going to replace it with 5x. So instead of it being x minus 6, this becomes 5x minus 6. And in our denominator, instead of it being 3x plus 7, it's 3 times 5x plus 7. So just notice everywhere that I had an x, I replaced it with, in this case, 5x. So my numerator stays 5x minus 6. And in my denominator, I distribute 3 times 5x. That gives me 15x plus 7. So h of 5x equals 5x minus 6 over 15x plus 7. So next we're given a graph of a function, and it's asking us to find h at -1. So remember, in previous problems, whatever was inside this parentheses was our x value. So what we're going to do in this case is come to our x-axis on our graph and find -1. So -1 is 1 unit to the left of our origin, and we're looking for the corresponding y value. Well, in this case, the y value that corresponds to -1 is directly on the axis, which means the answer would be 0. Let's look at one more. Let's say we were asked to find h of -3. So we come to -3 on our x-axis, and we find the corresponding point on the graph, which we have to move up to hit that point on the graph. So the corresponding y value in this case would be 4. One more. Let's say we're asked to find h at -4. So we come to -4 on our x-axis and either move up or down depending on where our graph is. In this case, we move up until we hit the graph, and the corresponding y value in this case would be 6. Okay, so let's look at coordinates on a graph. And remember again, just for review for most of you, the first value is our x value, and our second value is our y value. So in this case, it's asking us to find the coordinates of Paris. So Paris is located here on our graph. So our starting point is our origin. So to find our x value, we determine how far left or right we're moving in order to get to where Paris is located. So in this case, we have to move to our left 4 places. So that means our x value is -4. And then from there, how far up or down do we move to be on that point Paris? In this case, we have to move up positive 4 places. So the coordinates of Paris would be negative 4, 4.